Need some motor control in your life? Let's fire up the TB6612FNG Dual H-Bridge motor controller. All the parts, all the code. Come on in. Welcome to Maker's Digest. This week we're going to have a look at the TB6612FNG Dual H-Bridge motor driver. You can use this board to drive two DC motors or a single bipolar stepper motor. I recommend a different driver for steppers, and we'll get to that in a different episode. Today we're going to focus on using this driver to drive two DC motors. It's small and simple and would be great for a little robot or something. It uses MOSFET H-bridges instead of BJT H-bridges, which allows for a little more current to the motor. The logic voltage is between 2.7 and 5.5 volts, while the motor voltage can operate in an optimum range of 4.5 to 15 volts. Max current is 3 amps per channel and continuous current of 1 amp per channel. And when I say TB6612FNG, that's referring to the IC itself. You can pick these up for about $6 or $7. A little pricey for a motor controller, but you pay extra for the current that's available. In another episode, we'll cover the L298N, which is cheaper but has a max current of 2 amps per channel. We focus on implementation here. We're going to get right to it. This tutorial will show you how to connect the motor controller to an Arduino and a Raspberry Pi. I don't cover everything it can do. We cover just enough so you can get it working and experiment with it or get it into your project fast. So let's jump over to the workbench and get started. All right, here we go with the Arduino first up. For this connection, we're going to need the motor controller itself. We're going to need our Arduino, of course. I've got two DC motors here. These are little gear motors, but any small DC motor that fits the parameters of the motor controller will work. You just want to know which side is positive, which side is negative. Of course, it doesn't really matter because if you have voltage on one side, that controls the direction of the motor, but if you want them to travel in the correct direction, know which side is positive. And on these, I've got them marked with a little red dot. We will also need 13 male-to-male jumper wires. Let's get going on this. Oh, the other thing we're going to need is external power. So I've got this hooked up to our bench power supply that we built a couple episodes ago, and it's got 5 volts for these motors. It'll be just fine. You don't want to run motors even this size off of the Arduino because you're not going to get much torque out of it because there's not a lot of current that comes out of this. So you want your external power, which is a battery or whatever it is if you're building a robot or whatever. Let's get started. We'll hook up power to the rails here and get it into the motor controller. Right. See, I put these over here so I can deal with it. We always start with our ground, so we'll take ground off the Arduino, run that over here to the ground rail on the breadboard, take our 5 volts out of the Arduino into the voltage rail. We know it works because I've got my LED in there, right on. Now we're going to go into the motor controller itself. We need 2 for this. Put a little loop in it. Ground is the 3rd pin over on this side. And VCC is right next to that on the 2nd pin over. Now let's connect our external power. So the way that we do this is we're going to take ground off of our external power, and that's going to go to the ground rail here. that will tie all of these things together with one ground. So we've got this common ground here. We've got ground on the Arduino, we've got ground on the motor controller, and out to our external power supply. Now the voltage from the external power supply, we go directly to the motor controller on this pin here, which is called VM. I think that's for voltage motor, but that's where that one goes. And that, through this chip and on this board, is going to supply power directly to the motors and not pull it from here. This power is just the logic power for the board. Let's finish up on this side, and the next 4 connectors are for the motors, and it goes, there's my pointer. We got positive, negative, positive, negative. So this is channel A, this is channel B, I believe. All the markings are on the bottom, but yeah, this is either A or B. We'll take one motor. We've got our plus side, got the red dot, green in this case. And then we'll connect our negative side of that. Positive and negative. Now we've got everything powered and our motors connected. We can move on to connecting the logic to the Arduino. And a little bit about that, there's several pins that we're going to connect. For each motor, there are 3 pins, and they are PWM and then N1 and 2. PWM controls the speed of the motor, while N1 and 2 determine which direction the motor is going to turn in. Let's use blue for PWM. So this pin here, pointer, this pin here is PWM A for A channel motor. That is going to go to pin, PWM A is going to go to pin 3. We've got 0, 1, 2, 3. And the next 2 pins are a little deceiving because it's AN1 and AN2, but it starts with 2. So it's AN2 and AN1 rather than being 1, 2. Don't know why, but that's what it is. AN2 is going to go to pin 8. AN1 goes to pin 9. And now we have the next pin here is standby. That goes to pin 10. The standby pin will turn off and on the motors. So even if you have logic driving the motors and you switch off the standby, it will shut down the motors. And in fact, that's exactly how we have a function in the software that's called stop to shut down the motors and just stop. So that's how that works. The next 3 pins for the next channel are, let's see, B1, B2, and then PWMB. So B1 goes to pin 11, B2 goes to pin 12, and then PWMB is pin 5. So that should be it. Everything is connected. We've got all of our logic over here. Got all of our power connected. Motors are connected. Let's take a look at the software. As usual, wrote this on my time, not yours. I created some functions in here that are similar to what you would use to drive a robot. So for an example, it's probably not how I would write it if I was creating some kind of robotic control with these motors, because it's very, very basic. But it gives you an idea of how you can create the functions to start or forward, reverse, turn left, turn right, and stop. The first thing we need to do, and I guess I want to say, we're just using straight GPIO on these. We don't need any special libraries or anything, so this is just straight code with no external libraries. We set up all of our pins. We've got our standby pin on pin 10. Motor A, we had PWM A on 3, in 1 on 9, in 2 on 8. Motor B, PWM is 5, in 1, B in 1, 11, B in 2 is 12. And the setup is pretty basic on this. We just go through and set up everything as an output. So all the pins that we're using are all set up as outputs. In our loop, we're just calling functions. So we'll skip down to the functions and then we'll take a look at the loop to see what it's going to do. So here are the basic functions. You can see that they are calling another method or function called the run motor. That's where all the good stuff happens. So let's go take a look at that. And here it is. Run motor. It has 3 parameters. One is the motor, the speed, and the direction. The first thing that happens in here is we turn on that standby to high, and that enables the motors. We set up the direction pins here, so we create new variables and we set it statically here to low and high. If the direction is 1 other than 0 as opposed to 0, it flip-flops that. So pin 1 becomes high and 2 becomes low. And this is the portion where we send the command to the motor to make it go. We set the direction to AN1 and AN2 on with these values that we set here, and then we tell it how fast to go from the speed parameter on the PWM pin. So that's motor 1, else it's motor 0. And that's how that goes. And then here I showed you, or I told you, that the stop function, all it does is it sets the standby pin to low, which just turns this all off. You know, if you wanted to be more elaborate with this, in here you could set the in pins to null and PWM to 0, and be pretty precise about everything stopping exactly. But this, for this purpose and this demonstration, we just set that to low and they'll stop. And when we have these intermediate functions here that run both the motors, like forward, all we're saying is run motor 0 at a speed that is from a parameter, and the direction is the same on both of them, run forward. Reverse, same thing, just backwards, and turn right and left is just the directions are opposite on this. So one motor will go this way, one motor will go this way, the robot will turn. And then up here in the loop, we just have examples of what's going to happen. So we're going to go forward and this is the speed, forward at 128 for 2 seconds. So if you want to run the motors for a certain amount of time, you have to introduce the delay in here for how long they're going to run before you send it to stop. So we'll move forward for 2 seconds and then stop the motors. This delay at the end of this little block is just a delay between the next thing that happens, which is we'll run them in reverse at full speed for 2 seconds and then stop the motors. We'll delay for 1/4 of a second, then we'll turn left at 1/4 speed. Is that right? Yeah. For 2 seconds, stop the motors, and delay for 1/4 of a second. And then we'll turn right at full speed for 2 seconds, stop the motors, and we've got a delay before it loops back up here to run forward again. Let's see if it works, see if I hook this all up correctly. Here we go. Upload. And it's not working. Let's shut that down. I didn't turn the power supply on. So that's a good example. We ran the software and the motors did not turn. That's because the power, external power, was not on. So it showed you that it's not pulling power through here. It's only driving that logic on there. So turn on power supply. Let's try this again. There it is. And I've got my finger on them because they're loud and rattle around without that, like this. Oh, no, they're not doing it this time. There it is. Let's shut that down. There we go. We have Arduino all hooked up, motors running with some software to get you started on, well, at least going forward, backwards, turning left and right. Right on. Let's move to the Raspberry Pi. All right, here we go with the Raspberry Pi. For this, we're going to need the motor controller, a Raspberry Pi. We've got 4 male-to-male jumpers. And what is this? I think it's 9. Those are the wrong ones. 9 male-to-female jumpers. Let's go in the same order. We're going to connect power to the power rail here. And then we'll get our logic power set up. We'll get our external power, and then we'll do the logic lines into this side. Here we go. So we need male to female to come off the Raspberry Pi. And we're going to come off of ground, which is pin 6, and this is pin 1. So we count 1, 2, 3, 4, 5, 6. All the way over here to ground. 3.3 volts off of the Raspberry Pi. You can use 5, but I'm using 3 for this example. And that's on pin 1. We'll run that over here. And we know we have power because we got our light that came on. Now that we have power to this rail, we can power the motor controller. Just like to hook up ground first. Ground is the 3rd pin. And now for the 3 volts, which is the 2nd pin. This motor controller doesn't have any lights or anything on it to let us know that it's on, but that's okay. We'll take its word for it. Sure. Now we want to power or get our external power set up on the board. So ground, we go from our ground on the external power into ground here, and now we're all tied together. Got our ground loop from the Raspberry Pi over to the rail. This is tied in to ground, and so is our external power supply. Now we'll get the plus 5 volts for the motors, and that goes into this first pin right here. alignment there. There we go. And this power is on. I forgot to turn it on for the Arduino side if you didn't watch that, and it wouldn't run, but it's on. I can see the light. Let's finish up on this side, get our motors in. These next 4 pins are channel A and B, positive, negative, positive, negative. Take on these, got the red dot, green is positive in this case. Go positive, negative on that motor, and this motor, positive, negative. Now let's hook up the logic components, and it's the same thing. We've got, each motor has PWM in 1 and 2 for each motor, and then we also have a standby pin that will turn the motors off and on. So when you set that high, they go into functioning mode, and when you set that pin to low on standby, it turns them off. So everything will still work, it just won't route the power through the controller to the motors. First things first, PWM-A. That is going to go to pin 12 on the Raspberry Pi. So we'll count that off as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That goes to PWM-A. And then this is A1, AN1, and AN2. It's not 1 and 2, it's 1 and 2. And on the bottom side of this, it's marked out what all these pins are, but this version of the board doesn't have them marked on the top, so you just Google it and you'll find lots of images, and if the board looks like this, they're all the same. So AN2 is going to pin 18. So if this is pin 12, we've got 13, 14, 15, 16, 17, 18. AN1 goes to pin 16. So we're 12, 13, 14, 15, 16. And now we'll do standby. Let's use yellow for standby. It's the next pin over. So the channels are separated by the standby pin. You've got your PWM and inputs, standby, and then inputs and PWM. Standby goes to pin 22. So if this is 8, I don't remember. Let's count them off again. 22, right there. And then B1, and now this one is 1 and 2, and then PWM. So B in 1 is pin 15. So 2, 4, 6, 8, 10, 12, 13, 14, right behind green. Now we've got B2 goes to pin 13, 2, 4, 6, 8, 10, 13, and then PWMB, which is on pin 11, 2, 4, 6, 8. Come on. There we go. Okay. Got everything hooked up. We can take a look at the software now, run it, and see if it all works. As usual, wrote it on my time, not yours. The only we have to import a couple of modules here. The first one is sleep, as usual, because that's where you get a delay. So from time we import sleep, and we're going to use a standard Raspberry Pi GPIO for this. That's all we need. Make it easy. We're going to use the mode, the board mode, so we can refer to the exact pin numbers here as numbered on this, because it's easier for you to see translated when you're looking at the schematic that I provide and the pin table, and then see the numbers here. If we did BCM, which is the Broadcom numbering for this chip, then you would end up seeing these would all be totally different numbers. Even though it's plugged into 12, they call it 22 or whatever. And that has its benefits, but I want to try to standardize on that for you guys, so my schematics and my code all kind of match up the same. We set them all up as outputs here. We configure our 2 PWM pins as PWM, and this thing wants a PWM frequency of 100. So we set that up here. And then of course with our PWM, as we've seen, you have to run the start command to get them fired up. As with the Arduino, I've created the same kind of things. So down here in our loop, we're calling a function called forward, reverse, turn left, turn right. Those are all defined up here. Those are kind of intermediate functions that call the run motor function. So let's take a look at run motor. I made it as similar to the Arduino code as possible, where we turn on the GPIO. We turn on the standby, we set it to high, which turns the motors on, ready to use. We set some internal variables here for N1 and N2, and that lets us flip-flop the direction pretty easily by setting them to high, 1 high, 2 low, and if direction is 1, which is reverse, we just flip-flop them. For the motor, if the motor is 0, we're going to set the output of the N1 and N2 pins to these values of GPIO, low and high, depending on which direction we're going in. And then we set the PWM value, which is the speed, on that PWM-A pin. Same thing for motor B. We set our in, flip-flopped or not, and then the speed. And of course here we have our stop, GPIO.output, and we set it to low. That'll shut them down. Down here in the loop, same thing. We run forward at this speed. Oh, and the PWM range is 0 to 100 and not 0 to 255. So keep that in mind while you're doing that. We're going to run forward, sleep. We're going to run forward for 2 seconds, stop the motor, and then 1/4 second delay. We're going to run in reverse for 2 seconds, stop the motor, turn left for 2 seconds, stop the motor, turn right for 2 seconds, and then stop the motors. Now let's see if I connected all of this right. Python. There they go. Right on, we did it. Loop through and do it again. And now they're rattling all over the place, so I'll put my finger on it so you can hear me again. That's really all there is to it. It's easier than some of the other things that we've worked with where we need crazy libraries and have to go through the installation of all of those. These just use standard GPIO that's kind of comes with the systems here. And so there you have it. have fun with this and go build robots. Right on. Well, there you have it. TB6612FNG Dual H-Bridge motor controller running 2 DC motors on an Arduino and a Raspberry Pi. Don't forget, all the code we used in this episode is on GitHub, linked in the description below. There's also a link to where to buy the parts for this tutorial if you want to try it for yourself. Now that you have everything that you need, go be creative and share with me what you make. I can be found on Facebook, Instagram, Twitter, Patreon, and all those. If you like this video, please consider subscribing and ringing that little bell so you'll be notified when a new episode is available. Thanks for watching, and until next time, keep making.